Let's take a look at tangent vectors and normal vectors. If I have a curve like this, and I'm looking at a specific point, there's a tangent vector associated with that point, and we'll be talking about one with a unit, which means the distance or magnitude of one distance. And so if that's our tangent, our normal for 2 dimensions is going to be at a 90-degree angle here. It's orthogonal, which means the dot product of them is equal to 0. And that's going to be the normal, principal unit normal vector. So those are the 2 items we'll be working with here. Plus there would be an acceleration component for each one of these, which we'll look at those formulas. Now our definition of the unit tangent vector, let C be a smooth curve represented by R, an open interval I. The unit tangent vector, T, is represented as T is equal to R prime over the magnitude of R prime. And of course R prime is not equal to 0. So let's look at our first problem. R is equal to 5ti plus t to the third j. Now that little mark I put over there, that indicates the vectors, since I can't bold on this tablet. And it says find a unit tangent vector of the curve at the specified value of the parameter. Well, we need to find r prime. Well, if we take derivative of that, that gives us 5i plus 3t squared j. Now, what they're specifically asking for here is a unit tangent vector. They're asking for t. Now, at the moment when you start working with items actually in the formula, see how we got r prime here, and this is r prime? We can go ahead and plug in the t value. So, r prime of 1 is going to equal to 5i plus 3 times 1 squared j. So I'm plugging in the t equals 1 wherever there's a t. So r prime 1 is going to equal to 5i plus 3j. Now we also need the magnitude. So we'll take the square root, and we'll take 5 squared plus 3 squared. So you take whatever's in front of your I and j and square them. That gives us 25 plus 9, which gives us the square root of 34. So our principal, or our unit tangent vector at 1 is going to equal to r prime at 1 divided by the magnitude of r prime at 1. So we're going to have 5i plus 3j over the square root of 34. And I split that up. 5 over square root of 34i plus 3 over square root of 34j. And that's going to give us 5 square root of 34 over 34i. Multiply top and bottom by square root of 34. Plus 3 square root of 34 over 34j. And that's our answer. Let's look at our next one. R is equal to 2 cosine t I plus 3 sine t j, and t is equal to pi over 6. Instructions are to find unit tangent vector. So we need r prime, so we'll find derivative. Well, the derivative of cosine is negative sine, so this becomes negative 2 sine ti plus, then derivative of sine is cosine, so this becomes 3 cosine tj. Now we're trying to find a unit tangent vector, so we just found r prime, so we can go ahead and plug in our t value. So r prime of pi over 6 is going to equal to negative 2 sine pi over 6i plus 3 cosine pi over 6j. Now, sine of pi over 6, if I look at my unit circle, pi over 6 right here, this is going to be square root of 3 over 2 and 1/2. So sine is going to be equal to 1/2. So we got negative 2 times 1/2 I plus 3, and cosine is square root of 3 over 2. So we got square root of 3 over 2 j, which gives us negative I plus 3 square root of 3 over 2 j. That's r prime of pi over 6. Okay, well, let's find the magnitude. So we have the square root of negative 1 squared plus 3 square root of 3 over 2 squared, which gives us 1 plus, when I square the 3, I get 9, and I square the square root, I get 3, so that's 27, and I square the 2, and I get 4, which gives us square root of 31 over 4. It's a mixed number. 1 times 4 is 4, plus 27 is 31, which I can split up. Square root of 31 over square root of 4, which gives us square root of 31 over 2. Okay. So for our unit tangent vector, it's going to be equal to r prime over the magnitude of r prime. R prime was negative I plus 3 square root of 3 over 2j all over square root of 31 over 2. Now I can flip that fraction, multiply times each one of these pieces, so that gives me negative 2 square root of 31i plus 2 square root of 31 times 3 square root of 3 over 2j, which gives us negative 2 square root of 31 over 31i. Here the 2's cancel, and we got 3 square root of 3 over square root of 31j. Can't leave the square root down below, so we'll multiply top and bottom by square root of 31, and we get 3 square root of 93 over 31j, and that should be an I. And assuming no basic math error, that'd be your answer. And let me save that page. Tangent vectors and normal vectors. Okay, so calc 3, tangent vectors and normal vectors. Page 01.pdf. There we go. Now, note, given a tangent vector, t, at a point, x1, y1, z1, tangent vector of the form k, where it's k is a number of some sort, then we get inside our vectors, we got a1, b1, and c1. Direction numbers correspond to the a1, b1, and c1. That's our a, b, and c. In our parametric equations, x equals at plus x1, y is equal to bt plus y1, and z is equal to ct plus z1. So let's look at a problem dealing with that. we got r is equal to t squared I plus 5tj plus tk at the point 0, 0, 0. Okay, first thing, we got to find the unit tangent vector. So I need r prime. The derivative of that gives us 2ti plus 5j plus k. Now, I want to find the tangent vector, so I can go ahead and plug in my t, but I need to find my t. Now, this right here is our x value, and this right here is our x value. So we'll set those equal to each other. So I got t squared is equal to 0. This is our y value, and this is our y value. So we're going to set those equal to each other. So I got 5t is equal to 0. And we got this is our z, and this is our z. So we're going to set those equal to each other. So t is equal to 0. Now if I solve each one of these, I get t is equal to 0, t is equal to 0, and t is equal to 0. We're looking for what these have in common, unless one of these is always true, like 5 equals 5 type of deal. Well, obviously, they all have t is equal to 0, so that's what we're going to be going with. So over here then, I'm going to plug in 0. And this gives me 2 times 0i plus 5j plus k. So that's going to equal to 5j plus k. Well, we need a magnitude, which is going to be square root of 5 squared plus 1 squared, which is square root of 26. So then our unit tangent vector is going to be equal to r prime over the magnitude of r prime. So r prime was 0. Because we were actually wondering at that point. So that's equal to 5j plus k over square root of 26. Which gives us 1 over square root of 26, 5, wait a minute, can't read my own writing. That's a j. Okay, scratch that. 0, 5, and 1. That's a j there. So there was no I, so that's why we put a 0 there. Now, this is also equal to square root of 26 over 26, 0, 5, and 1. Now that's our tangent vector. First thing it's asking for. Well, from that, they're going to give us our direction numbers. This is A, this is B, and this is C. That's this, A, B, and C. Well, this up here, this is our x1, this is y1, and this is z1. So our formulas say x is equal to at plus x1, and y is equal to bt plus y1, and c is equal to ct plus z1. Let me double check those. Yeah, okay. So you just plug in what you just found. Well, a we said was 0, so this is 0t plus x1, which is 0. So that gives us x equals 0. Y is equal to bt, so we got 5t plus y1, which is 0. So we got y is equal to 5t. And I'm not sure why I put a c there. Scratch that. That should be z. So we got z is equal to 1t plus 0, or just z is equal to t. And those are our parametric equations. Okay, let's look at this one. Got r is equal to 2 cosine t and 2 sine t, and then 3. And it's at the point square root of 3, 1, and 3. Now I know I'm going to need my t here in a second, so I might as well just go ahead and find it. Again, this is my x part here. I'm going to set that to equal to my x part over here. So I got 2 cosine t is equal to square root of 3. This is my y part, and I'll set it equal to the y part over here. So I got 2 sine t is equal to 1. And this is my z part, and I'll set it equal to my z part over here. So I got 3 is equal to 3. Well, if I solve these for cosine, this is cosine is equal to square root of 3 over 2. And this is sine t is equal to 1/2. Now this is 3 is equal to 3, so we can ignore that one. So since these are cosine and sine, we're looking on our unit circle where cosine is equal to square root of 3 over 2 and sine is equal to 1/2, which occurs at t is equal to pi over 6. Okay, so same instructions. They want us to find unit tangent vectors. We need r prime. Well, derivative of cosine is negative sine, so this becomes negative 2 sine t. Derivative of sine is cosine, so this becomes 2 cosine t. And derivative of 3 is 0. And we can go ahead and plug in our pi over 6, because we're finding the unit tangent vector, which uses r prime. So at the moment you're working with something that's actually in the formula what you're trying to find, you can plug in your t value. Don't want to plug it in too soon. I don't want to plug it in up here at r, because r isn't in our formula. Okay, so we're going to have negative 2 sine pi over 6, 2 cosine pi over 6, and then 0. Well, sine of pi over 6 is 1/2, so we got negative 2 times 1/2. And here we got 2, and cosine of pi over 6 is square root of 3 over 2. 0. Okay, those 2's cancel, and I got negative 1. And those 2's cancel, we got square root of 3, and then 0. And then we want to find a magnitude at pi over 6. So it'll be the square root of negative 1 squared plus square root of 3 squared plus 0 squared. Which gives us 1 plus 3, which would give us 2. So our tangent vector at pi over 6 is going to equal to r prime at pi over 6 over the magnitude of r prime of pi over 6. So we're going to have negative 1 square root of 3 and 0 over 2, which gives us 1/2 negative 1 square root of 3 and 0. So this is our unit tangent vector. And the directional numbers come from this part. So this will be A, this will be B, and this will be C. And of course our initial point, this will be x1, y1, and z1. So our formula says x is equal to at plus x1, y is equal to bt plus y1, and z is equal to ct plus z1. So we got x is equal to negative 1t plus x1, which is square root of 3. So we got x is equal to negative t plus square root of 3. Y is equal to b, so square root of 3t plus y1, which is 1. So y is equal to the square root of 3t plus 1. And z will equal to 0, that's where c is, 0t plus 3. Yeah, 3. So we end up with z is equal to 3. And that's the second thing they're asking for. They're asking for the unit tangent vector and then a set of parametric equations for the line tangent to the space curve at point P. Let me start a new page, and we'll do this problem. And time for the tablet to blow up, so let me bring up another one. There we go. And 5. So we got r equal to t squared and 3t minus 1 at the point 2, 4, 5. Well, we know from our previous two examples that we're going to need t, so let's go ahead and find it. Again, we're going to set the x parts equal to each other, so we'll set t equal 2. We'll set the y parts equal to each other, so t squared is equal to 4. And we'll set the z parts equal to each other, so 3t minus 1 equal 5. And of course, this is just t is equal to 2. This is square root property. Drop your squared, put a plus or minus square root on the other side, and we get t is equal to plus or minus 2. Here, take negative 1 over. We get 3t equals 6, or t is equal to 2. So what they all have in common is t is equal to 2. So that's the one we're going to use. Well, we need r prime. Derivative of that gives us 1, 2t, and 3. Now we're trying to find a unit tangent vector, so we can go ahead and plug in our value. So r prime of 2 is going to equal to 1, 2 times 2, 3. Which gives us 1, 4, and 3. Now we need the magnitude at 2. So it'll be the square root of 1 squared plus 4 squared plus 3 squared, which gives us 1 plus 16 plus 9, which gives us square root of 26. So then our tangent vector at 2 is going to equal to r prime at 2 divided by the magnitude of r prime at 2. So we're going to have 1, 4, 3 divided by square root of 26, which gives us 1 over square root of 26 and then 1, 4, 3, which gives us square root of 26 over 26, 1, 4, and 3. So these are going to be our direction numbers, A, B, and C. And we got our point, which is x1, y1, and z1. So we'll go ahead and label that. That's x1, y1, and z1. This is our tangent vector, so I'll go ahead and circle that. So then we're going to have x is equal to at plus x1. Y is equal to bt plus y1. And z is equal to ct plus z1. A was 1, so we got 1t plus x1, which was 2. So we got x is equal to t plus 2. Here we got y is equal to b, which is 4. So we got 4t plus y1, which is 4. So that gives us y is equal to 4t plus 4. And z is equal to c, which was 3. So 3t plus z1, which is 5. And we got z is equal to 3t plus 5. So these are our parametric equations go along with that. Now, depending upon what your directional numbers are, then you might see have this come out different. So keep that in mind. Now, the principal unit normal vector goes like this. N is equal to t prime over the magnitude of t prime. Now, if we're asked to find the principal unit normal vector, at the moment we find t prime, we can immediately plug in our value. Now, there's another shortcut that goes along with this, which I'm going to show with this first example. So let's take a look at this one. Because these get kind of long working them with the formula. These shortcuts really do help save time on these. Okay, so we got r is equal to t squared I plus 5tj at t is equal to 3. Let's first start off finding the tangent vector. So we need r prime. R prime is going to equal to 2t I plus 5j. And even though I said you don't want to plug in this number, with this shortcut I'm going to show you, it's really is handy to do that. So let me go ahead and plug in that number. So we got 2 times 3i plus 5j. So we get 6i plus 5j. Well, let's find the magnitude of r prime at 3. That's going to equal the square root of 6 squared plus 5 squared, which is 36 plus 25, 61? Yeah, square root of 61. Okay. So t at 3 is going to equal to r prime at 3 over the magnitude of r prime at 3. So we're going to have 6i plus 5j over the square root of 61, which gives us 6 over square root of 61i plus 5 over square root of 61j. And we probably don't want to switch that over yet to the proper form. We don't really care anyway. This shortcut only applies to 2 dimensions, and if we have our graph and we're looking at a point and we got our tangent vector, then our normal vector is going to be orthogonal to that, forming a, well, that didn't look orthogonal, but it's supposed to be. Let's try it again. It's going to be orthogonal to that. And it's going to be opened up toward the concave side of the curve. So we're going to use that to very quickly get the principal unit normal vector. And let's see how. Let's first go graph this. So I come here, and I know you can't see this, it's pretty small. I'm choosing window, choose 2 dimensions. And I'm choosing equation, and I'm choosing the second one, parametric. Now for f of t, I'm going to put in t squared. What's before my I? So I got t, and then I'll put caret 2, and then I'll tab down to g of t, and I'm going to put in 5t. So that's what's in right for our j. Now the low t is 0, that's fine. High t I'll put in 4, and I'll put an arrow where it says put arrow at. I check that, and I'll put one at 2. And arrow size 10, that's fine. I'll click OK. And now I'm going to press my down arrow, scroll out, and that way I can see the direction. Now, at this point here, if I were to plug 3 in for my original r, if I put 3 in here, I got 3 squared, which is 9, and if I put 3 here, it's 15. So the point I'm looking at is 9, 15. Well, let's go sketch a tangent vector at that point. So I'm going to choose equation, and I'm going to choose segment, and I'll choose xy. Now for my x1 and y1, I'll choose 9 and 15. Now for my x2 and y2, I'm going to put 9 plus, and then my I component is 6 over square root of 61. So I'm going to put 9 plus 6 divided by square root of 61. And for y2, I'm going to put 15 plus 5 over square root of 61. Now I'm going to put an arrow where it says arrows. I'll click the P2 and I'll change my arrow size to 14. And then I'll click OK. Now let me put a point at 915 so you can specifically see it. I'll choose equation, choose point, choose XY. I'll put in 915. And I'll make it solid. And dot size, I'll make it 4 so you can see it. Oops, that's a little bit too big, isn't it? Let me edit that and make that 2. Okay. And let me click over here in the wind plot and zoom in. And I'm doing my up arrow to scroll down there so you can see it. And a little bit more. And I'm right arrowing there. And you can see that's my, though we'd have to zoom in really to see it very well, that's my my tangent vector I just found, my unit tangent vector. So it's got a magnitude of 1. Well, my normal vector I know is going to be orthogonal to that, and it's going to be opening in toward our concavity. So it's going to open down like this. Which means, if you think of your x and y's from where this point is, my x is going to be positive, my y is going to be negative. So if I come over here, our normal vector at 3 is going to be the same values. We just have to think which way it's curving in. Let me see. So I have this. So I have my going that way. So this is going to be going this way. Well, see how the x is positive and the y is positive for my tangent? For my normal, the x is going to be positive, but the y will be negative. So this will be 6 square root of 61 I minus, wait a minute, screwed that up. These values actually flip. So this becomes 5 square root of 61 I minus 6 square root of 61 j. Because this is going this way, so my x part has to be positive, and then it's going down, so it has to be negative. And they swap values. See how they swap values? So this is t at 3. Then you get that. Now if I were to sketch that on here, if I go to equation and choose segment and choose xy, my x1 is 9, my y1 is 15. This will be 9 plus 5 divided by the square root of 61. And this one will be 15 minus 6 divided by the square root of 61. I'll do my point there. Arrow size is fine. I'll click OK. And see how it opens like that? Now, some of these I try to do in my head to think that through. I try to do that in class, and hopefully I didn't screw up the signs. But that's what allows you to find it very quickly. So, multiply top and bottom by square root of 61. So we got 5 square root of 61 over 61i minus 6 square root of 61 over 61j. And that's our answer. Now again, this swapping business here only works with 2 dimensions, and you have to make sure your signs are correct. The direction that this is going, the orientation, your tangent keeps going that same direction. So I know it's not going back this way. Let me save that page. And we'll look at our next problem. Looks like number 7. Grab a drink here. Is that? I only had one of those? Guess so. Notice this one has X, Y, and Z, so it has 3 dimensions. So this is a little bit harder. So R is going to equal to natural log of t I plus t squared j plus 5k t is equal to 1. Well, first off, I'm going to need my t value eventually, I know. So, oh, we already have our t value. Never mind. So let's find our tangent vector first. So let's find r prime. Well, the derivative of natural log of t is 1 over t I plus 2tj. And 5k, since that's a 5, it goes to 0 and drops away. And we'll need the magnitude of r prime, which is going to be equal to the square root of 1 over t squared plus 2t squared. So I just square whatever's before my I and j. And that's going to give us 1 over t squared plus 4t to the... try it again. 4t squared. Okay. Now I can take this and multiply times that and add it to that, and I'm going to get 4t to the 4th plus 1 over t squared. This is a mixed number form. I took 4t squared times t squared gives me 4t to the 4th, and I add to 1. And I can split this up into square root of the top, square root of the bottom, but square root of t squared is just t. So this is the square root of 4t to the 4th plus 1 over t. Okay, so our tangent vector now is going to be equal to r prime over the magnitude of r prime. So we're going to have 1 over ti plus 2tj over the square root of 4t to the 4th plus 1 over t. And we're going to flip that, multiply times our top piece here, multiply times each piece. So this will be t over square root of 4t to the 4th plus 1 times 1 over t I plus t over square root of 4t to the 4th plus 1 times 2t j. Okay, let me just double check everything here. Okay. These t's cancel, and we're going to have, 4t to the 4th plus 1 to the negative 1/2 power, I. Those t's canceled. This is the 1/2 power, and I took it up on top and became negative 1/2 power. Plus, t times 2t is 2t squared, and I'll take the square root up on top. And that gives us 4t to the 4th plus 1 to the negative 1/2 j. Now, I want to take that's t now. I need t prime. So I want to take the derivative of that. Well, this is the product rule over here. This will be p, and this will be q. P prime will be 4t. Q prime, take your power, put it out in front. Then we got 4t to the fourth plus 1. Lower your power by 1, so that'll be negative 3/2, times the derivative of what's inside the parentheses, which is 16t to the third. Which gives us 1/2 times 16 is 8. So we got negative 8t to the third over 4t to the fourth plus 1 to the 3/2. Positive 3/2, that is. Okay, so the product rule will have p prime q plus p q prime. So for our derivative, now this one right here, that's what we just found with q here. We took the power, put it in front, lowered it by 1, multiplied times the derivative of what's inside. So I can steal this. This is going to be negative 8t to the third over 4t to the fourth plus 1 to the 3/2 power I plus p prime. P prime is 4t times q, which is 4t to the fourth plus 1 to the negative 1/2, plus p, which was 2t squared, times q prime, which was negative 8t to the third over 4t to the fourth plus 1 to the 3/2 j. Assuming no basic math error. Well, my t that I'm going to be plugging in was t is equal to 1. I'm going to go ahead and do that because I'm wanting to find the principal unit normal vector, and its formula involves t prime. So once we get down to something that's in the formula, we can go ahead and plug in our 1. And that should make it a little simpler. Well, 1 to the third is 1, so it drops away. So we've got negative 8 over 1 to the fourth is 1 times 4 is 4 plus 1 is 5. So we've got 5 to the 3/2 I. Over here, put 1 in here. We got 4 times 1, that's 4. Times 1 to the fourth is 1 times 4 is 4 plus 1 is 5. So 5 to the negative 1/2. Plus 1 squared is 1 times 2 is 2. Times 1 to the third is 1 times negative 8 is negative 8. Basically, all these t's are going to drop away when we put 1 in there. So that gives us 5 to the 3/2 j. So that gives us negative 8, 5 square root of 5 I, plus 4 over 5 to the 1/2 minus 16 to the 5 to the 3/2 j, which gives us negative 8, 5 square root of 5 I, and I'll multiply the bottom part here by 5. Because 5 to the first, that'll give me 1/2 plus 1 gives me 3/2. And I'll multiply the top part by 5. So that gives us 20 over 5 to the 3/2 minus 16 5 to the 3/2 j. Which gives us negative 8, 5 the square root of 5i. 20 minus 16 is 4 over 5 square root of 5 j. Are those both i's and j's? Yeah, it looks like it. Okay. And, oh, I sure hope I didn't make any mistake there, because I'm getting ready to save this page and go to the next page. Well, I won't double check. I'll hope and pray. Okay. So let me write this down. So t prime of 1 is equal to negative 8 over 5 square root of 5I plus 4 over 5 square root of 5j. And actually, I could probably do part of it right here, to be honest, even though I'm about out of space. Now that's t prime, I should say. So then to find the magnitude of that, it's going to be the square root of a negative 8, 5 square root of 5 squared, plus 4, 5 square root of 5 squared, which gives us 64 plus 16. 64, 16, what is that, 80? And when you square the 5, that gives you 25. You square this, that gives us 125. Which, both these are divisible by 5, at least. So it's 116. This one's 25, which gives us 4/5. And now, to find our n, go right here. N of 1 is going to equal to t prime at 1 divided by the magnitude of t prime at 1. So I'm going to have this. So I got negative 8, 5 square root of 5I, plus 4, 5 square root of 5j, all over 4/5. Now I'm going to flip that 4/5 and multiply it times my top part, which when I flip this, it becomes 5/4, and the 5 is going to cancel there. And then I'm going to divide each one of these by 4. So that gives me negative 2 square root of 5I plus 1 over square root of 5j. And miracle of miracle, this is actually a unit vector, so that makes me feel good. That's kind of a check. So that gives us negative 2 square root of 5 over 5I plus square root of 5 over 5j as our answer. And it did fit all that on there. Okay, so let me save that. Time for that to blow up. So bring up a new tablet, and we'll look at problem number 8. And let me grab a drink here. This one won't be too bad. It's asking us to find a velocity, acceleration, tangent, and normal. But it's 2 dimensions, so we can use our cheats on that, our little shortcuts. So r is going to equal to 5t squared I minus 3tj, and t is equal to 1. Okay. Well, we know our velocity, which is the first thing they're asking for, is r prime, which we're going to need anyway for t. So derivative of 5t squared is 10t I minus 3j. So take derivative of each component. And that's one of the things they're asking for right there. Oops, I guess I shouldn't have circled yet, because they want us to plug in the number, I think. Let me see. By the vector. Okay, so so then our velocity at 1 is going to equal to 10 times 1I minus 3j. So that's going to equal to 10I minus 3j. That's our velocity vector at t is equal to 1. Now our acceleration. Well, that's we keep taking the derivative of that. That's the second derivative of r, which that gives me 10I, and the negative 3 goes to 0, so that drops off. So then our acceleration at 1, since there is no t, is just 10I. Now they're wanting the tangent, and I got r prime, which is right here, so I want to find the magnitude of r prime. Now, actually though, I'm going to go ahead and plug in a number. R prime was equal to 10ti minus 3j. We plug in a number here, but I'll plug it in again, so just see it with our notation. So we're plugging in t is equal to 1. So that gives us 10I minus 3j. And then we want to find the magnitude of r prime of 1, which is going to be the square root of 10 squared plus negative 3 squared, which is going to give us, that's 109, square root of 109. So t is going to equal to r prime over the magnitude of r prime, which means that t of 1 is going to equal to r of 1, r prime of 1 I should say, 10I minus 3j over the magnitude, which would be the square root of 109. It's not very pretty. That gives us 10 over square root of 109i minus 3 over square root of 109j. Now, I'm going to work with this form, but the simplified form would be 10 square root of 109 over 109i minus 3 square root of 109 over 109j. So that's our tangent vector at 1. Now we're going to use, again, a relationship between the tangent vector and the normal vector to very quickly come up with that. Well, let's see where our point's at. If I put 1 in for t, I put 1 here, I got 1 squared, 5 times 1 is 5. If I put 1 here, I got negative 3. So the point we're looking at is 5, negative 3. Let's graph this. I'm going to choose window, choose 2 dimensions. I'm going to choose equation, parametric. For f of t, I'm going to put in 5t squared. So 5t care 2, and then I'll put a negative 3t for g of t. Okay, and then I'm going to put in, got 0 there, and I'll put 3, I guess, I don't know. And I'll click put an arrow at, and I'll put it at, I don't know, 2. Because our t, I think, was 1, wasn't it? Yeah, t is equal to 1. So let me click OK. And then I'm going to zoom out, so I'm doing my page down. Okay, so we got that. Well, let's go put a point at 5, negative 3. So I'll do equation, and I'll choose point, and I'll choose xy. And I'll choose 5, negative 3. And click OK. So there's our point. Now I want to do my show my tangent vector, which is this one, right? Or I want to work with this one. It's easier. 10 over square root of 109. So I'm going to take that x value. I'm going to do an equation and choose segment and then choose xy. And our point was 5, negative 3. So put in 5, negative 3 for the x1 and y1. Now for x2, I'm going to have 5 plus the I portion of the tangent vector, which is 10 divided by the square root of 109. So 5 plus 10 divided by the square root of 109. And then I'm going to have, from my y2, I'll have negative 3 plus whatever's before my j, which is negative 3 divided by square root of 109. So I'll just say negative 3 minus 3 divided by the square root of 109. And I'll put an arrow P2 and I'll make it 14 so I can see it a little bit, and then I'll do OK. Not very viewable, but if I zoom in, you can see it. So the normal was going to go up like this. It's got to go toward your concavity, which means my x is going to be positive and my y will be positive. Okay, x is going to be positive, y is going to be positive, which means that if I came up with this, then my normal is going to equal to 3 square root of 109 over 109i plus 10 square root of 109 over 109j. Again, the trick is these swap. You see how the values swap. And I just have to make sure my signs are correct. So, and some people can think it through their head. You know, if it's going up like this, then the x value is increasing and the y value is increasing, so both are positive. Now, it doesn't matter what quadrant it's in. That's not what we're looking at. We're looking at whether it's increasing or decreasing from where it was. And that's it for that problem. Okay. Well, we got some other formulas to help us find the acceleration at the different components, at the tangent and the normal, and our acceleration of the tangent. For the tangent, you know, when you get a tangent vector, you can find using these formulas. So the dot product of a and t, or dot product of v and a divided by the magnitude of v. Then for the normal, or acceleration, the dot product of a and n, or any of these other ones. And the last one's kind of a nice one to use. So let's take a look at some problems dealing with this. Grab a drink. And do I got room here? I'm going to save this just in case. There we go. And number 9. Got r is equal to 1 minus t squared I plus 2t squared j, and t is equal to 2. Now notice this is 2 dimensions, so we can do that little trick again. Once we find t, we can very quickly get in. They just flip-flop, and you just have to make sure your signs are right. Well, I need r prime to begin with. So the derivative of this gives us negative 2ti plus 4tj. And let me look at my formulas actually. What do I need here? Okay, I need acceleration and t. So I'm going to find r prime of 2 is equal to negative 2 times 2i, so we're just plugging in 2 for the t, plus 4 times 2j, which gives us negative 4i plus 8j. And then the magnitude of r prime of 2 is going to equal the square root, and we'll take each one of these numbers. The negative 4 will square it, and the 8 will square it. So that gives us 16 plus 64, which gives us square root of 80. Don't know if it'd be real beneficial. Yeah, I guess it would be to simplify those a little bit. this is 16 times 5. Yeah. So this becomes 4 square root of 5. So then t at 2 is going to equal to r prime at 2 over the magnitude of r prime at 2. So that's going to be negative 4i plus ha over 4 square root of 5, which is going to give us negative 4 over 4 square root of 5i plus 8 over 4 square root of 5j, which gives us negative 1 over square root of 5i plus 2 over square root of 5j. And that gives us negative square root of 5 over 5i, multiply top and bottom by square root of 5, plus 2 square root of 5 over 5j. And that's our tangent vector at that. Okay, our normal vector is going to be these flip-flopped. We just have to make sure our signs are right. That's only trick to that. So let's take a look at this graph. Close that. I do window, 2 dimensions, choose equation, parametric. For f of t, we'll put in 1 minus t squared, 1 minus t care 2, and then this next one I think is 2t squared. Yeah. So 2t care 2. And low t is 0. High t I'll put in 3. I'll put an arrow at 1 because we're looking at 2. And then I'll click OK. That's weird. Is that really a line? X is equal. Yeah, I guess so. So if I go and put the point there, if I put 2 in, this would be 2 squared, which is 4. 1 minus 4 is negative 3. If I put 2 in here, 2 squared is 4 times 2 is 8, so we got negative 3, 8. So I'm going to go put a point there. I guess I better zoom out a little bit more. So do equation, choose point, choose xy, and put in negative 3, 8. And from there, for our tangent vector, we're going to add this on to the negative 3, 8. So we'll have negative 3, and then we'll add on that to get to the new x value. So I'm going to go here, and I'll do equation, and choose segment, choose xy. And x1 is negative 3, this is 8. Then x2 will be negative 3 plus, I guess minus 1 divided by square root of 5. So minus 1 divided by square root of 5. And this will be 8 plus 2 divided by square root of 5. Then I'll put an arrow at P2 and make the arrow size 14 and click OK. Okay, so that's what that looks like. Now, unfortunately on this one, if I try to do the shortcut, let's just go through the formula. Let's find t, and the old way. So r prime is equal to negative 2ti plus 4tj. And then I need the magnitude of that. So I'll have square root of negative 2t squared plus 4t squared, which is going to give us the square root of 4t squared plus 16t squared, which gives us square root of 20t squared. Well, this is 4 times 5, so 2 can come out and a t can come out. So we got 2t square root of 5. Okay, so our tangent vector is going to be r prime divided by the magnitude of r prime. So we're going to have negative 2ti plus 4tj over 2t square root of 5. Problem with this is, see how these t's drop away? So when I put this one over this one, the 2 is going to be gone, t is going to be gone, and we're going to have negative 1 over square root of 5i. And here, the t's cancel away, and we're going to have 4 divided by 2 is 2, so we'll have plus 2 over square root of 5j, which is what we came up with right here. The problem with this is there's no variables left. So when I go and take my derivative of that, what we're going to find out gives us is this is going to give us a zero vector, which means for our normal vector it doesn't exist. There is none. Now you can see that in the graph. The fact you come up with a straight line, if you think about it, you know, the normal vector opened up toward the concavity. Well, a straight line doesn't have any concavity, so that right there tells you there's a slight problem. So you have to be careful. The shortcut works, but not if it doesn't exist. You can flip those around and have no problem with it, but when you look at the graph, it's just like you can see they don't exist. Okay. Well, let's find this now. So we need to find a. We already have t, or we could use this one if we wanted to. But a is pretty easy to get. Now our velocity is the same as r prime. So our velocity is equal to r prime, which was equal to negative 2ti plus 4tj. So our acceleration is going to equal to, the derivative of that is negative 2i plus 4j. So then from our formula, acceleration for the tangent is equal to the dot product of these. And I didn't have to plug in our t value here because there was no t values. So we got this one here and t up here. And I could choose this one if actually let me choose this one because that's t also. Not t that though. What value did I plug in? 2. Okay. So dot product of negative 2i plus 4j and negative square root of 5 over 5i plus 2 square root of 5 over 5j. Okay, multiply the what's before our i's together. So we got negative times a negative is positive. We got 2 square root of 5 over 5. And then multiply together what's in front of our j's, which would give us plus 8 square root of 5 over 5. Which gives us 10 square root of 5 over 5, which gives us 2 square root of 5. So we had to make a basic math error. Okay. Now the other one, and like I say, there's different ones you can choose. Probably this very last one is always going to be the easiest one. This says we need the magnitude of a. So let's find that. So magnitude of a is going to equal the square root, and here's a. So we got negative 2 squared plus 4 squared, which gives us 4 plus 16, which is 20, which gives us 2 square root of 5. We also need the one up here, which we have, so that's no problem. So now we're ready to find the acceleration for the normal. Okay, so that's going to equal to square root of the magnitude of A at that value squared minus what we just found up here squared. Well, let's see, magnitude of that is 2 square root of 5, so we got 2 square root of 5 squared minus this squared, which is 2 square root of 5 squared, which gives us 0. And you think about it, that makes sense, considering we're dealing with a line and what we found out about the normal vector. So let me save that. There we go, 6. And let's look at our next problem, number 10. So R is equal to e to the t I plus e to the negative t j, and t is equal to 0. Okay, let's find our different pieces. We know we're going to need our velocity. It's asking for that. Or it's not asking for that. Sorry, but we need it. So that gives us r prime. So the derivative of e to the t is e to the t with an I. Derivative of e to the negative t is e to the negative t times the derivative of the exponent, which gives us negative e to the negative t j. Now our acceleration is going to equal to the second derivative of r, which will be e to the ti, and this flips the sign again, so plus e to the negative t j. Now, let's see, what all do we need? I'm going to find a of 0. I'll plug 0 in for t. So that gives us e to the 0 I plus e to the negative 0 j, which gives us anything to the 0 power is 1. So this is I plus j. We'll need that. Now r prime. We're also going to need to find out what that is. So r prime of 0 is e to the 0 I minus e to the negative 0 j, which gives us I minus j. Okay. Now we're also going to need the magnitude of r prime and the magnitude of a. So let me find that. Magnitude of r prime at 0. And r prime 0 was I minus j. So we're going to have square root of 1 squared plus negative 1 squared, which is square root of 2. And the magnitude of a at 0, we'll take the I plus j here, and we got 1 squared plus 1 squared, which is square root of 2. And I think those might be the only pieces we need. So let's find the tangent vector first. The tangent vector at 0 is going to equal to r prime at 0 over the magnitude of r prime at 0. Well, r prime at 0 was equal to I minus j. Over the magnitude of r prime of 0, which was square root of 2. So that's going to equal to the square root of 2 over 2i minus square root of 2 over 2j. Now our normal vector, assuming it exists, our normal vector at 0 is going to be these two flipped. It's kind of boring because they're both square root of 2 over 2. We just have to figure out what our signs are going to be. And I shouldn't have to graph this. I should be able to think it through. But let's take a look at the graph. I'll be lazy. So close that. I'm going to do window, 2 dimensions. I'll do equation, parametric. And our f of t is going to be e to the t, which is exp beginning parentheses t. And then g of t will be exp beginning parentheses negative t. And we're going to have 0, and high t is going to be, let's say, 2. And I'll put an arrow at t is equal to 1. And click OK. Okay, now if I look at what point I'm examining this at, if I were to put 0 in for the t here, I'd have e to the 0, which is 1. And this would be e to the negative 0, which is also 1. So the point we're dealing with is 1, 1. So I'm going to go put a point there. So do equation, point, xy, and 1, 1. And click OK. Now our tangent vector. We just came up with this right here. So I'm going to have choose equation, choose segment, xy. Starts at 1, 1. And then x2 will be 1 plus square root of 2 over 2, whatever's before our I. I'm looking at my tangent vector here. So square root of 2 divided by 2. And y2 will be 1 plus negative square root of 2 over 2. So I guess 1 minus square root of 2 over 2, like that. And I'll put an arrow on that, and arrow size will do 14. Click OK. And there's our tangent vector. So our normal vector is going to go off this way, which means the x is increasing and the y is increasing, so both of them are positive. So if I can find my tablet here, both of these are positive. So that's our answer. Okay. Now let's find these other ones. Let me grab a drink here. And this is going to equal to the dot product of A, and this is going to be A at 0. Dot product of A at 0 and T at 0. So realize that it's not the generic ones, it's after we plugged in the values. Well, where's A of, okay, here's A0, which is I plus J. So we got I plus J, dot product of T of 0. Where's T of 0? T of 0 is this right here. So that'd be square root of 2 over 2I minus square root over 2J. Well, each of these are 1, so this is kind of a boring one. This will be square root of 2 over 2 plus negative square root of 2 over 2, which gives us 0. Now for our other one, we'll use this one, and I think I found both those pieces. So we'll have square root, the magnitude of A at 0 squared minus this. So that's going to give us magnitude of A at 0 was square root of 2. So this is square root of 2 squared minus, this was 0, so that's 0 squared, which gives us the square root, and when you square that, that gives you 2, so it gives us square root of 2. And those are our answers. What are these next two? These next two are just using a shortcut again, so they won't be too bad to find. So we'll go ahead and find those. So number 11. R is going to equal to 5t squared I plus 5tj, And T naught is equal to 1/5. And they're saying sketch a graph, which we've been doing on every problem. And then they say note that n points toward the concave side of the curve. They're telling us go ahead and use a shortcut here. Well, I've been using it all along. So I need to find r prime. It's going to equal to 10ti, take derivative of each component function, plus 5j. And then we'll plug in our value. So we're plugging in 1/5. So we're going to have 10 times 1/5 I plus 5j, which gives us 2i plus 5j. Now I also need the magnitude of r prime of 1/5, which is going to be the square root. And I'll take the 2 and the 5 and square them. So I got 2 squared plus 5 squared, which gives us, that's 25, that's 4, so that's square root of 29. So, what are they asking for anyway? Sketch the graphs. I'm just going to find them. Well, I'll sketch one of them. So t at 1/5 is going to equal to r prime at 1/5 divided by the magnitude of r prime at 1/5. So we're going to have 2i plus 5j divided by the square root of 29, which gives us 2 over square root of 29i plus 5 over square root of 29j. Okay. Now I know for my normal vector at 1/5, I know these are going to be swapped. So this will be 5 square root of 29i, and this will be 2 square root of 29j. Question is what sign is going to be. If I were to put in 1/5 up here, 1/5 squared is 1 over 25 times 5 gives me 1/5. And if I put 1/5 in here, that'll give me 1. So that'd be the point I'm dealing with. So let's go graph this. I'll do window, choose 2 dimensions, choose equation, choose parametric. For f of t, I'm going to put in 5t squared. So 5t caret 2. And for g of t, I'm going to put in 5t. And 0 for my low t. And then I'll put in 2 for my high t. And I'll put an arrow at t is equal to 2, so I can see the orientation. Do a page down to try to find my arrow. There it is. Okay. Now we're examining it at the point 1/5 1. So if I go put a point there, I'll do equation point xy, 1 divided by 5 and 1. Click OK. So we're looking right there. Well, we just found our tangent vector, so let's look at that. Again, what I'm doing is I'm taking my starting place, the 1/5 1, and I'm adding on the x component onto the 1/5, and I'm adding on the y component to the 1. So over here, I'm going to do equation segment xy, and x1 will be 1/5, and y1 will be 1, and x2 will be 1/5 plus 2 divided by square root of 29. And y2 will be 1 plus 5 divided by square root of 29. And I'll choose arrows at P2 and I'll make it 14 and I'll click OK. So there's my tangent vector. Well, I know my normal vector is going to be orthogonal to that, so it's going to come down like this. The x value is increasing, but the y value is decreasing. X is positive, y is negative. So that'd be my signs for that. Now if I were to graph it, again I'd start with my basic point here, 1/5 1, and I'd add the x part onto the 1/5, and I'd add on the y part to the 1. So let's go ahead and do that just to show the graph. So I'll do equation, choose segment, choose xy. And x1 will be 1/5, y1 will be 1, x2 will be 1/5 plus 5 divided by square root of 29. So 5 divided by square root of 29. And then y2 will be 1, then minus 2 divided by square root of 29. And I'll put an arrow on that and click OK. And if it looks like it's orthogonal and it's pointing toward your concavity, then you know you've got your normal vector correct. And I'll get there eventually. Here we are. So let me put these in the right form. So this one would be 2 square root of 29 over 29i plus 5 square root of 29 over 29j. And this one would be 5 square root of 29 over 29i minus 2 square root of 29 over 29j. And see what else they're asking for in that problem. Sketch a graph, sketch of vectors. Okay, yeah, I guess we did that. Let's look at our next one. Let me save that page. I see the end in sight. Oops. Time for that to blow up. Okay. Number 12. So we've got R is equal to 3 cosine t I plus 3 sine t j. And it says we're interested in t naught is equal to pi over 2. Okay, well, let's find t. This would be a circle, wouldn't it? We'll find r prime first. So the derivative of cosine is negative sine, so this will be negative 3 sine t I plus 3, and then derivative of sine is cosine, so this would be 3 cosine t j. And if we plug in the pi over 2, this becomes negative 3 sine pi over 2i plus 3 cosine pi over 2j. Now sine of pi over 2 is equal to 1, so this is negative 3i. Cosine of pi over 2 is 0, so 0 times 3 is 0, times j is 0, so that drops away. So then our magnitude of r prime at pi over 2 is going to equal the square root of negative 3 squared, which gives us square root of 9, which gives us 3. So our tangent vector at pi over 2 is going to equal to r prime at pi over 2 divided by the magnitude of r prime at pi over 2. Well, r prime was negative 3i, and the magnitude is 3, so that just gives us negative I. Yeah, see, I probably don't even need to, I could probably do this. X is equal to 3 cosine t, y is equal to 3 sine t. Divide both sides by 3, we got x over 3 is equal to cosine t. Y over 3 is equal to sine t. Square both sides, so we got x squared over 9 is equal to cosine squared, and y squared over 9 is equal to sine squared. Then add the left sides, and we got x squared over 9 plus y squared over 9 is equal to cosine squared plus sine squared. So we got x squared over 9 plus y squared over 9 is equal to 1. Multiply everything by 9, and we got x squared plus y squared is equal to 9. Which means we got a circle of radius 3. Go around like that. Okay, at pi over 2. If I put in pi over 2 here, cosine of pi over 2 is 0, so that gives us 0 for the x. And if I put in pi over 2 here, I get sine pi over 2, which is 1, so that'd be 3. So we got 0, 3, which would be right here, which would seem to make sense for pi over 2, doesn't it? Okay, so we said the tangent was negative I. Didn't draw my circle very well, but negative I would look like that, which then the normal would look like that. So, and this one's a little bit weird because how do you swap them when there's not both of them? But our normal at pi over 2 is equal to negative j. Oh, let me save that, and then we'll do the last problem. Number 13. Got R is equal to 5ti plus 4tj minus 2tk. And t is equal to 2. And I'm going to find these four again. And it says hint, find a, t, and a sub t and a sub n, then solve for n. So r prime is going to equal to 5i. Let me think here for a second. Yeah, that might be okay. Yeah, I'll go with this. Plus 4j minus 2k. Sometimes I make these numbers up, they don't come out quite right. Now, our acceleration is the second derivative. So, which would be the 0 vector. That's why I said, I'm not sure if I really like that, but maybe that'll make it even a little bit easier. So let me find r prime of 2. So plug in 2 for the t. Well, there is no t, is there? So I got 5i plus 4j minus 2k. And then I'll find the magnitude of r prime of 2, which is the square root of 5 squared plus 4 squared plus negative 2 squared, which is 25 plus 16 plus 4, which is square root of 45, which gives us 3 square root of 5. That's 9 times 5, so it gives us this. So, t of 2 is going to equal to r prime of 2 divided by the magnitude of r prime of 2. Which is going to give us r prime of 2 is 5i plus 4j minus 2k divided by 3 square root of 5. Which gives us 5 over 3 square root of 5i plus 4 over 3 square root of 5j minus 2 over 3 square root of 5k. Which gives us 5 square root of 5 over 15i plus 4 square root of 5 over 15j minus 2 square root of 5 over 15k. which gives us square root of 5 over 3i plus 4 square root of 5 over 15j minus 2 square root of 5 over 15k. And that's our tangent vector at that t value. Okay. Now here we're going to find dot product of a and t. So we need a. This may not come out good at all. That's going to be 0, won't it? Everything's going to be 0. Well, you get the idea anyway. So, you know, if I found this at 2, well, that's just the 0 vector. So then this says find the dot product of a and t. Oops. It's acceleration, that's not a vector. So a of 2 and dot product of t2. Well, since this is the 0 vector, taking the dot product of whatever, then 0 times anything is 0, and then you add them all together and you get a bunch of zeros. Okay, then this one. Well, if I way too easy, I think. Squared minus, but you see the formula anyway. Okay, so we plug in all that. The magnitude of that gives us 0, so this would be 0 squared minus, we said that was 0, so that's 0 squared, so that gives us 0. Okay, so we found all those different pieces. So now it tells us to go down here, plug into this formula. So we got a of t is equal to this well, this right here was, what was that? Was a 0 vector. And this right here was 0 times t, which is all of this, square root of 5 over 3i plus 4 square root of 5 over 15j minus 2 square root of 5 over 15k, like that, plus, and then this was 0 times n. Now, if this didn't come out so flaky, 0 times this gives us a 0 vector, plus 0 times n. Then we would solve this, get n by itself, and that would allow us to find it without finding, go through all that work. This was a poor example because everything was pretty basic here. Now, if you think about it, what this represents, if I got x is equal to 5t, y is equal to 4t, z is equal to negative 2t, we're going to have a line, which it doesn't have a normal, which is what this indicates to us. So no normal vector. Anyway, you see the thought process anyway behind that. And I'm not going to try and make one of those up out of my head, or it won't come out good. There we go. And let me clear that. And stop the recorders. Hour and 40 minutes.